Let's study 9th Standard ICSE Chapter 1, Language of Chemistry, Sums. Let's start with exercise 1A. We'll do question 11 later. First, let's do question 15. Here, we have to write the acidic and basic radicals, and then we have to use the crisscross method to write the chemical formulae. Acidic radicals are the anions, and basic radicals are the cations. So we need to remember the valency table thoroughly. This is the valency table to be learnt thoroughly. First question A, barium sulfate. So we just write the cation and the anion. Always write the cation first, and then we do the crisscross. But before that, check if the valencies can be reduced. So 2 ones are 2 ones are. Note that this subscript cannot be cut. This remains as it is. So this one goes down here for barium, and this one goes down for sulfate. No need to write number 1. So the answer is BaSO4. Now the C question is calcium bromide. So I wrote the valencies. Now this 2 will go for bromine, and this 1 will go for calcium. So for calcium, no need to write number 1, it's understood. But for bromine, write 2. So the formula is CaBr2. Next, the E question is chromium sulfate. Chromium is Cr3+, sulfate is SO4 2-. It can't be reduced. So 2 goes down here to chromium, so I write 2 here. And 3 goes down here for sulfate. But since sulfate is a complex radical, that is, it has 2 elements, sulfur and oxygen. And this number 3 is for it entirely. So it's important to write brackets. If you don't write these brackets, then writing 3 will be quite confusing, because it would look like 43. And it would look as if this 3 is only for oxygen, not for sulfur. That's discrimination. We can't do that. All elements are born equal, and they have equal fundamental rights. So the answer is Cr2SO4 thrice. So tell me, how many oxygen atoms are there in this molecule? Well, it's 4 into 3, 12. Next, the G1 is stannic oxide. Stanness would be tin 2+, stannic is tin 4+, and oxide is always 2-. Tin has variable valency, like many transition elements. Here, reduction is possible. So 2 ones are, 2 twos are, and then crisscross method. So 2 goes out to O and 1 goes out to Sn. So the answer is SnO2. Next question, I is magnesium phosphate. So Mg2+, phosphate is PO4 3-. 2 goes down here, 3 comes down here. So we write like this. Keep in mind, here bracket is compulsory. Here, why did we write the bracket? Because there is only one element. But here we have a couple of elements, so bracket is required, because this 2 is not only for phosphorus but even for oxygen, whereas this 4 is only for oxygen. So how many phosphorus atoms are there in this? 2. How many oxygen atoms are there in this? 4 into 2, 8. Next, K is stannic phosphate. So stannic is Sn4+, and phosphate is PO4 3-. Crisscross method, and we get this answer. And finally, potassium manganate. Now manganate is MnO4 2-. If it was permanganate, it would have been MnO4 1-. So be careful about that. Crisscross method, and this is the answer. Next, let's do the 16th sum. Here, the formula is given, and we have to write the name. So we are going to do these sums. Mark the I1 as IMP. First of all, Ca3PO4 twice. Now, if this 3 comes out here and 2 comes out here, we realize that this is Ca2+ cation and PO4 3- anion. So this is nothing but calcium phosphate. So even here, knowledge of the valency table is crucial to write the names. K2MnO4. Well, again, if you take 2 out here, it's 2-. So it is not permanganate, it is manganate. And this will be potassium, of course. So potassium manganate is the answer. Next, this will be magnesium bicarbonate. Notice that 2 is from the valency 2+ of magnesium. So magnesium bicarbonate. Next, this is barium. But what is this? This 2 is from the valency of 2+, which came from barium. And there is no subscript out here. That means here the valency was -1. And when the valency is -1, ClO3 is chlorate. So it's barium chlorate. If you remember, ClO was hypochlorite, ClO2 was chlorite, ClO3 is chlorate, and ClO4 is perchlorate. So remember these differences. And finally, we have this molecule, which is a bit strange, because usually metals should be written first. Well, that's okay. It's still going to be lead written first here, and this is acetate. But lead has variable valency, 2 plus and 4 plus. So we'll have to mention which valency is being used here. Well, acetate valency is 1 minus. So that means there was no reduction possible. So this 2 subscript is definitely from here, 2 plus, which was crisscrossed. So this has to be lead 2 acetate. If you don't write the Roman number to show the variable valency, then you will not get marks. Now let's do exercise 1b. Let's start with question 4. Here word equations are given. So we are going to first convert it into a chemical equation, and then we are going to balance it. So the first one is carbon plus oxygen gives carbon dioxide. Note that carbon is a monoatomic molecule, but oxygen is diatomic. So whenever in the word equation you see elements like oxygen, nitrogen, chlorine, bromine, and hydrogen, these are all diatomic gases. So when these elements are alone, they are diatomic. Whereas metals like sodium, potassium, magnesium, calcium, iron, copper, they are all monoatomic. They can exist independently too in nature. So there, the valencies don't matter. When you write the elements symbol here, we don't have to worry about the valencies. The valencies come into consideration only when we write a compound molecular formula. Now balancing. We have to make sure that the number of atoms of each element is equal on LHS and RHS, that is reactants and products. I see that this is already balanced. Let's do the C1. The C question is calcium plus nitrogen gives calcium nitride. Now calcium is a metal, so just write Ca. No need to worry about the valency here. Plus nitrogen. Now nitrogen is a diatomic gas, so that's N2. And calcium nitride. Now here again we'll have to use a crisscross method mentally or in the rough. So calcium is 2 plus, nitrogen is 3 minus, reduction is not possible, 2 comes here, 3 comes here, so that's Ca3N2. So now we got the correct equation, but we have to balance it now. So we have 3 atoms of calcium, so write 3 out here, and 2 atoms of nitrogen, 2 atoms of nitrogen, done. So that's balanced. Great. Let's move on to the next one. E. It's magnesium plus sulfuric acid gives magnesium sulfate plus hydrogen. So first of all, magnesium will be monoatomic. Sulfuric acid, you should know the formula of all the acids. And magnesium sulfate, yes, 2 plus and 2 minus got cancelled, so this is the correct formula. Plus hydrogen. Hydrogen is a diatomic gas, so this is how we'll write it. Don't just write H. It is always H2 if hydrogen is alone. It is in diatomic molecular formula. Now let's do the balancing. We see that the number of elements are already equal on LHS, RHS, so this equation is already balanced. Now we move on to question 5. Let's do the A1. So we'll just copy these equations one after the other. Mark IMP sums as I, J, N. So let's start balancing the first one. Iron plus water gives triferric tetroxide plus hydrogen. We always balance oxygen in the end. So let me first balance iron on both the sides. We have 3 Fe, so here 3 Fe. Hydrogen is 2, fine. But oxygen is 4, and here oxygen is just 1. So I'll have to increase this. Let me write here 4. But that changes hydrogen as well. Hydrogen becomes 4 into 2, 8. So I'll have to increase the hydrogen out here. Let me put a 4 out here. Check. Is it balanced? Yes, it is. Done. Next, the C1. Zinc plus potassium hydroxide gives potassium zincate plus hydrogen. The equation was already given in the question. Let's balance it now. So zinc 1, zinc 1. Potassium 2 atoms. So here I'll put a 2. Potassium 2 atoms. And oxygen 2 atoms, oxygen 2 atoms, hydrogen 2 atoms, hydrogen 2 atoms. So now it's balanced. Next, the E question. Well, PbO, which is lead monoxide, plus ammonia gas gives lead plus water plus nitrogen. Initially, I had noticed that we have 2 nitrogen atoms here, so I put a 2 out here. So that became 2 nitrogen atoms here as well, but that became 2 into 3, 6 hydrogen atoms. So then I put 3 out here, so that became 3 into 2, 6 hydrogen atoms. But then oxygen became 3, so I put a 3 out here, so even oxygen atoms became 3. But then again, lead became 3, so I put a 3 out here, so there were 3 lead atoms, and now this is a balanced equation. Next, here lead sulfide plus oxygen plus lead monoxide plus sulfur dioxide. First, I'll put a 2 out here to increase oxygen to 4, because here we had 1 plus 2, 3. Then I put a 2 out here, so now it's 2 plus 2, 4 oxygen atoms, but then lead is 2. So let me put a 2 out here. So now number of lead atoms are same. But now sulfur is also 2, whereas here sulfur is just 1. So I'll have to increase it, I have no choice. So now sulfur atoms are same. But that increases oxygen. Now it's 2 into 2, 4, plus 2, 6. But here we have only 4, so we'll have to increase this. So let's make it 3. Now the number of atoms of oxygen are also equal, and this is a balanced equation. You'll have to rewrite it, write A and S answer, and rewrite the final answer neatly. Next, let's do the I question. It's an IMP one, so let's do it with the long cut method. This is how you should do all the sums. So first I've listed out the number of atoms of each element. Note how oxygen is 4 plus 2, 6 plus 1, 7. So I wrote 7 out here. So let's start. Sulfur 1 and 1 is fine, but hydrogen is just 1 and here we have 4. So let's increase this. Let's put a 4 out here. So this becomes 4. But that will affect nitrogen as well. So nitrogen becomes 4. And that will change oxygen too. 4 into 3, 12. So let's make it 12. Now let's check again. Nitrogen is less. Let's increase it. Let's put a 4 out here. So that will become 4. Let's talk about oxygen now. 4 into 2, 8, 12. Plus 1 is 13. Oops. Just a difference of 1. So we'll have to do everything all over again. Let's increase it to 5 so that oxygen becomes 15. We have no choice here. This disturbs everything. So don't forget to change the other elements' numbers. So again, let's increase hydrogen. But hydrogen is here as well as here. Which one should I disturb? Hold on. Let's go for nitrogen. That's straightforward. We have to do a 5 out here. So that becomes 5. And oxygen now becomes 5 2s are 10. Plus 4, 14, 15. And hydrogen is 2 plus 2, 4. Again, that won't work. We'll have to increase it further. So let's go for this one because we have only 2 elements here. So if I put a 2 out here, that becomes 2 into 2, 4. Plus 2, 6. So this becomes 6. But that increases oxygen yet again. It becomes 16. We'll have to put a 6 out here. We have no choice. So this becomes 6 and this becomes 6. And oxygen now becomes 18. Now nitrogen is less. So let's put a 6 out here. That becomes 6. Let's see what happens to oxygen. 6 into 2, 12. Plus 4, 16. Plus 2, 18. Oh, great. Now everything is balanced. So that's the final answer. You should rewrite it. Write A and S answer and write the equation neatly. Now similarly, let's do the J1. I have mentioned the number of atoms of each element in the same order, of course. We always balance oxygen at the end. Notice how chlorine is 2 plus 2, 4. So let's try to increase hydrogen to 2 out here because it's 2. Let's put a 2 out here. Okay, chlorine becomes 2. That's not enough. I'll have to increase it further. So let's make it 4. But then hydrogen becomes 4 as well. Don't forget to change that. Let's increase hydrogen here. Let's put a 2 out here. That's 4. But that changes oxygen to 2. So, is it balanced now? Yes, it is. Write the whole answer again. Don't forget to write it again. You can't leave it like this because there are cancellations here, which is not good. Now let's do the L sum. Potassium 1 and potassium, there are 2. So even without checking for other elements, I know I have to put a 2 out here. Now I'll check the other elements. Chlorine is 2, chlorine is 1 plus 1, 2. Oxygen is 2, oxygen is 1 plus 1, 2. Hydrogen is 2, hydrogen is 2. Oh, that was easy. That's balanced. Now N sum. Again, it's an IMP sum, so we'll do it in a long cut way. Lead is 3 and we have only 1 lead out here. So let's increase it. Let's put a 3 out here. But that will change chlorine. 3 into 2, 6 plus 2, 8. Next, hydrogen is less out here. And even chlorine is less out here. So let's increase it directly. I'm going to jump to 8 because I know that it is a requirement. 8, 8. Hydrogen will become 8. We have no choice. But to increase it further, put a 4. That becomes 8. That increases oxygen too. It becomes 4. Which is automatically equal now. Great. So that's the final answer. Now the P1. Sodium bicarbonate gives sodium carbonate plus water plus carbon dioxide. 2 atoms of sodium. So let's put a 2 out here. So we have 2 atoms of sodium. Notice we can't put any number out here. No, we can only write numbers in the beginning of each molecule. So hydrogen 2 atoms. So hydrogen 2 atoms. Carbon 2 atoms. So carbon 1 plus 1, 2 atoms. Oxygen 3 into 2. Don't forget to multiply. 6 atoms. 3, 4, 5, 6. Done. This is balanced. Now the R1. Well, phosphorus is 1. Phosphorus is 1. Hydrogen, I've got 2 plus 3, 5. And here only 1. So perhaps I should put a 5 out here. Let's hope it works. But then nitrogen becomes 5. And here the nitrogen is only 1. So let's put a 5 out here. Now let's hope oxygen is equal. 5 into 3, 15. 5 into 2, 10. 11 plus 4, 15. Great, it's balanced. Students, when you do the homework sums and even all these sums, please do it by the long cut method only, because once you are expert in it, only then you can do it mentally directly. Next, let's do exercise 1C. Let's start with question number 8. 8b, potassium bicarbonate plus sulfuric acid gives potassium sulfate plus carbon dioxide plus water. So first of all, we have to get the equation right. For that, we need the knowledge of valencies. Now let's try to balance the potassium first. We have 2 atoms and only 1 atom, so let's put a 2 out here. Now what? Hydrogen is 2 plus 2, 4. Here hydrogen is only 2, so definitely I'll have to put a 2 out here. Carbon, that becomes 2 now, and here there's only 1, so I'll have to put a 2 out here. Oxygen later, please. Sulfur, there's only 1 sulfur and 1 sulfur, so that's equal. Now let's talk about oxygen, since all other elements are equal. 2 into 3, 6, plus 4, 10. And here, 4, 2 into 2, 4, plus 2. So 4 plus 4 plus 2, 10. Great, it's balanced. Now the D question. Chlorine plus sulfur dioxide plus water gives sulfuric acid plus hydrochloric acid. Or rather, hydrogen chloride. When dissolved in water, this becomes hydrochloric acid. Anyway, let's go to the balancing part. Chlorine, 2 atoms and only 1 atom here. So put a 2 out here. Sulfur, 1 atom and here 1 atom. Fine. Hydrogen, 2 atoms. 2 plus 2, 4 atoms. So we'll have to increase hydrogen. Put a 2 out here. Now let's talk about oxygen. 2 and 2, 4 atoms. And here 4. So done. It's already balanced. Next, the F1. The F question is copper plus nitric acid gives you copper nitrate plus nitric oxide plus water. It's an IMP sum. Writing the correct formulae is half the battle won. Copper, nitric acid, yeah, copper nitrate, we have used valency 2 plus, so crisscross method, remember? So that's why the brackets appeared. Nitric oxide is NO, also called nitrogen monoxide. You need to remember these formulae. Plus water. Here the crisscross method won't be useful because it's a covalent bond, not an ionic bond. So number of atoms of copper, 1 and 1, fine. Hydrogen is a bit less here, even nitrogen is less, and even oxygen is less. So let's directly try 3 first of all, because nitrogen is 3, so I have to make it a 3, which will increase hydrogen also to 3. And oxygen will become 9. Not good enough, let's go ahead. Now nitrogen is equal, but hydrogen is less, let's increase that. The only way to do that is by writing a 2 out here, but that will make it 4. But that will increase oxygen as well. So that becomes 3 into 2, 6, plus 1, 7, plus 2, 9. First of all, list all the elements and the number of atoms. Notice how oxygen is 3 into 2, 6, plus 1, 8. And nitrogen is 2 out here, plus 1, 3. Now, number of copper atoms are equal. Hydrogen is less, nitrogen is less, oxygen is less. So let's directly increase nitrogen. Let's make it 3. So hydrogen becomes 3, nitrogen becomes 3, and oxygen becomes 3 into 3, 9. Now we'll have to increase hydrogen out here. So we'll have to put a 2. So that this becomes 4. Notice how oxygen also increases and becomes 9. But now the hydrogen is less out here. So we have no choice but to increase it further, 4. So hydrogen becomes 4, nitrogen becomes 4, and oxygen becomes 4 into 3, 12. Now we'll have to increase nitrogen as well as oxygen out here. So let's try to do that. If I put a 2 here, it seems to work. Nitrogen becomes 4, 2 plus 2, but oxygen becomes 10. I want to increase oxygen further. So which one should I increase? This, or this? Now here's the tricky part. Ideally, we would like to increase this one, thinking that only 2 elements will get disturbed. But if I try to increase the oxygen here, even nitrogen will be increased. And if nitrogen is increased, I'll have to increase this. And if I have to increase nitric acid out here, that will affect hydrogen and oxygen a lot. Because if I put a 5, it becomes 5 into 3, 15 directly. So what we'll do is we'll try to increase this first of all. Because that way we will be able to increase nitrogen, oxygen, both. And increasing copper is okay because we can always increase copper to whatever we want easily. So copper becomes 2, yes. Now the nitrogen becomes 2 into 2, 4 plus 2, 6. And oxygen becomes 3 into 2, 6 into 2, 12 plus 2, 14 plus 2, 16. So here, let's go for 6. because 5 will be insufficient, because 5 into 3 is only 15. This becomes 18. That makes this 6 and this 6. Now hydrogen has to be increased further. That's okay. We'll put a 3 out here. That makes it 6. And oxygen now becomes 3 into 2, 6 into 2, 12, plus 2, 14, plus 3, 17. Still falling short. We'll have to increase oxygen further. We will increase this to 4. Don't touch this one. Always increase number of water molecules in this scenario. So that makes hydrogen 8 and oxygen becomes 18. But then hydrogen is short here. Let's increase it to 8. So hydrogen becomes 8, nitrogen becomes 8, and oxygen becomes 8 into 3, 24. Now, let's increase nitrogen as well as oxygen by changing this. What if we make it 3 out here? So 3 into 2, 6 nitrogen atoms, plus 2, 8. So this becomes 8. Oxygen, 3 into 2, 6 into 3, 18, plus 2, 20, plus 4, 24. And copper changes to 3. That's okay. I can just put a 3 out here, and this becomes 3. So that's your final answer. Rewrite it. Write ANS answer and rewrite the correct answer without the cancellations. That's compulsory. Next, let's do the H1. Barium chloride plus sulfuric acid gives you barium sulfate plus hydrogen chloride or hydrochloric acid. Well, barium 1. Chlorine is 2 out here, so let's put a 2 out here. Hydrogen becomes 2, but hydrogen was already 2 here. And S1, O4, O4. Great, it's balanced. Next, the J1. Here we'll make a list of all the elements. Aluminium 4, aluminium is only 1. So let's put a 4 here. That becomes 4. Oxygen becomes 3 into 4, 12. Hydrogen becomes 3 into 4, 12 plus 4, 16. Carbon is 3 out here. So how do I increase it here? Tell me. Yeah, put a 3 here. So that becomes 3. That increases hydrogen even more. That becomes 3 into 4, 12, plus 3 into 4, 12. That's 24 hydrogen atoms. How do I make this 24? I'll have to put a 12 here. And that will increase oxygen to 12, which is matching. Great. So now it's balanced. Rewrite the final answer. Now let's do the L sum. It's IMP. It's a marathon sum. So be ready. Notice how number of chlorine atoms is 1, 2, 3, 4, 5. So let's start with that. Let's increase this to 5. So this becomes 5 and hydrogen also increases to 5. How do we increase hydrogen on the RHS? Put 3 out here. So this makes it 6. That increases oxygen 2, which becomes 3. In fact, I can see that this won't be sufficient. Oxygen is 4. Ideally, I balance oxygen in the end. But I may increase this further right now. Let me make it 4 straight away. So oxygen is 4 and 8. So I'll have to increase this to 8. Chlorine also becomes 8. How do I increase chlorine now? Everything else is balanced. Well, I've got 1, 2, 3, 4, 5. What if I put a 3 here? That's 6, 7, 8, 9. Or what if I keep it as it is and instead let me put a 2 out here or 4 out here. So 4, 5, 6, 7, 8. That seems to work. But that would increase potassium too much. And then to get potassium equal, I'll have to put a 4 out here, which will greatly disturb manganese and oxygen as well. So I don't want to increase this too much. Let me try 3 out here. That makes it 6, 7, 8, 9. Okay. So now I'll have to increase this one. Let's make this directly 10 because odd numbers won't work for sure. So this becomes 10 and hydrogen becomes 10. Let this be 5 so that hydrogen is 10. But now oxygen becomes 5. Uh-oh, that means I'll have to increase this. I can't prevent that from happening. Chlorine is less. I'll have to increase that as well out here. But let me increase this first. Put a 2 out here, 2 out here, 2. What else changes? Oxygen changes. 2 into 4, 8. How do I make this oxygen 8? Put an 8 out here. Okay. And 8 into 2, 16. That means to make this hydrogen 16, I'll have to cut it and write 16. I have no choice. Chlorine becomes 16. Let's check. Well, potassium is 1, so put a 2 out here. Manganese also put a 2 out here. Now only chlorine is left. Let's count again. 2 into 2, 4, that's 6. 3 into 2, 6, that's 12. I need more. 4 more. What if I add some chlorine atoms here? Make it 5. So 5 into 2, 10. Plus 2, 14. And plus 2, that's 16. Because 2 into 2 is 4. 4 plus 2, 6. 6 plus 10, 16. So this is the final answer. Write it neatly. Again on a new line. The numbers are 2, 16, 2, 2, 5, 8. If this was also an even number like a 6, then we could have reduced it further. Cut, and dividing the whole equation by 2. And that would be a simpler answer and the acceptable answer in the end. Next, let's do the N sum. So aluminium is 1 and 1. Sodium is 1 and 1. Oxygen is 2 out here and 2 out here. Hydrogen is 3 out here and 2 out here. So we'll have to increase this to make it 4. That means I'll have to increase this as well. And sodium increases. Can't help it. We'll have to increase this too. But aluminium becomes 2. So that's okay. I can just increase it out here. What about oxygen now? Well, 2 plus 1 is 3. 2 into 2 is 4. So I have to increase this further. Put a 2 out here. That increases hydrogen now. 2 into 2, 4. Plus 2 is 6. So how do I make this 6? Just cut this and write here 3. So 3 into 2 is 6. Check. Are all the atoms equal? Yes, it is. But you all don't do it directly. You all solve it in the long cut method. Next, students, notice here that in M sum there is no meta, and even in the N sum it's just aluminate. O is cancelled. P is IMP. So is R, L, J and F. All of these are IMP sums. So let's do the P sum. These are the number of elements that I've listed. Notice how chlorine is 6, 1, plus 3, 4, plus 2, 6. So let's increase potassium. That will increase chlorine further, 7. Chromium is 2 out here and 1 out here. So let's put a 2 out here. That increases chlorine even further. 2 into 3, 6, plus 2, 8, plus 2, 10. Oxygen is 7 out here. So definitely 7 out here as well. That becomes 7. That increases hydrogen to 14. That means I'll have to put the 14 out here. That will change chlorine to 14. So everything else is balanced, but chlorine is still less out here. So how do I increase it further? What if I put a 3 here? 3 2s are 6. Plus 6, 12, plus 2, 14. There you go. Pretty easy. And finally, let's do question R. So again, all the elements have been listed. Now chlorine is 1 and chlorine is 2. So let's increase chlorine on the LHS. Put a 2 out here. So that's 2. But that increases sodium as well. That's fine. We'll have to increase sodium here too. That increases hydrogen. It becomes 2 plus 2, 4. Sulfur, 2 increases. 2 plus 1, 3. Oxygen as well. 4 into 2, 8. 8 plus 4, 12. Plus 1, 13. Now, here, oxygen, hydrogen, sulfur, all of them are more. So let's increase it out here. Let's talk about sulfur, because we do oxygen at the end. And even hydrogen, second last. Sulfur, I'll have to put a 3 here to make this 3. That increases hydrogen to 3 into 2, 6. And oxygen also changes. 3 into 4, 12, plus 4, plus 2, 14. So let's increase hydrogen and oxygen. What if I put a 2 out here? I think it's done. Is it? Yes, it is. And then write the final statement again neatly. Don't forget it. Next. Question 9 is cancelled. Let's do question 12. Cancel the A part. Let's do the C one. Relative molecular mass of copper sulfate. Dot 5H2O. That's the water of crystallization. This dot means a weak chemical bond. It's not multiplication, okay? This is chemistry. So the relative molecular mass of CuSO4.5H2O is 1 atom of copper plus 1 atom of sulfur plus 4 atoms of oxygen plus 5 molecules of water. Now water we already know is 18 AMU because hydrogen is 1 plus 1, 2. Oxygen is 16. So totally it is 18. and substitute all the values. Notice that in the question, they always give you all the atomic weights. We don't have to learn them. So after substituting, multiply them respectively and add it. That's your final answer in atomic mass unit. Similarly, let's do the E question. That's actually sodium acetate. So here, again, relative molecular mass or molecular weight of sodium acetate is 2 atoms of carbon, 3 atoms of hydrogen, 2 atoms of oxygen, and 1 atom of sodium. The respective atomic weights have to be substituted, the answers have to be added, and that's your final answer in AMU. Next, let's do the G sum. Ammonium chloroplatinate. How many atoms of nitrogen are there? 2. 8 atoms of hydrogen, 1 of platinum, and 6 of chlorine. Substitute the values and get the final answer as 444 AMU. Why is chlorine atomic weight a decimal number? Well, that's an interesting question. Search it, and if you know the answer, message in the comments. Next, let's go for the 14th question, which is find the percentage mass of water in Epsom salt. Well, the molecular formula is given. So first of all, we will find the relative molecular mass of magnesium sulfate. This is the water of crystallization, of course. We'll do the 13th sum in a bit. So again, 1 atom of magnesium, 1 of sulfur, 4 of oxygen, and 7 molecules of water, which is 18 always. Substitute the values and we get 246 AMU. Out of this, what was the mass of water? It was 126. So out of 246, 146 is because of water. So what is the percentage? Well, we find the percentage, which is 51.21%. Always calculate up to 2 decimal places. Next. In the 15th sum, cancel the B part. Let's do the 17th sum. Urea's formula is given and we have to find the percentage of carbon in it. So as usual, we first find the relative molecular mass of urea. 1 atom of carbon, 1 of oxygen, 2 of nitrogen, 4 of hydrogen. Substitute the values, 60 AMU. Out of that, carbon is how much? 12, just 1 atom. That amounts to 20% of urea. Next, now let's do the 13th sum of empirical formula. We'll do the B and the D sum. Empirical formula simply means that whatever is the chemical formula, just try to reduce it to the simplest ratio. So 6 ones are, 6 twos are, and 6 ones are. So the answer is CH2O. Interestingly, even here, acetic acid, we can write it like C2 because 2 carbon atoms. H is 4 actually because 3 plus 1, 4. And O is 2. And then try to cut it. You will notice it's the same empirical formula we got. If I ask you what is the empirical formula of carbon dioxide, well, this itself is the empirical formula because it can't be reduced further. So that's how you solve empirical formula sums. And now, let's do exercise 1A sum. The 11th one, where the formula was given and we have to split and identify the basic and the acidic radicals. Remember, the basic radical is the cation and the acidic radical is the anion. Cancel the A1 and let's do B and D. In the B1, I see ammonium and sulfate ions. In the D1, I see zinc and carbonate ions. So that's how we write it. Make sure you write the correct valency and the name as well.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.